Good morning, my dear students. Our next problem is the voltage between the plates of parallel plate capacitor of capacitance 1 microfarad is changing at the rate of 5 Vs minus 1. So, what is the displacement current in the capacitor? So, what they are given in that problem? They are given that capacitor of capacitance and the rate of change of voltage, and then they are asking what is the displacement current in the capacitor. So first we analyze that what is the problem. Okay, so they are using parallel plates. So the parallel plates having the capacitor of capacitance 1 microfarad. So mu f means microfarad, that is a unit of capacitor of capacitance. So what is the meaning of capacitor of capacitance? The energy stored in that electrical device. So here we are using parallel plates capacitor. So that is also changed at the rate of 5 voltage second minus 1, right? So now we will go for the solution. So here the data are, so C means capacitor of capacitance 1 microfarad. It will be converted into Faraday, that's why it is multiplied with 10 to the power of minus 6. So the result is 1 into 10 to the power of minus 6 Faraday, and then dV by dt means the rate of change of voltage, that is also given in the data. It is 5 Vs minus 1. So you know the formula for displacement current or expression. So that is Id, that is equal to epsilon naught into d by dt into pi e. So epsilon naught is nothing but permittivity in free space. So d by dt, so that means the rate of change of electric flux. So the pi e stands for electric flux. So the electric flux is nothing but area per electric field. Okay, so that means the next step, the pi e is replaced as E into A, right? So E is electric field, A is the area, and then the next step, so the E is replaced by V by D. So that E is V by D comes with the potential difference. Okay, the electrical potential difference formula. So the electrical potential difference is V is equal to E into D. So here E stands for electric field. So D is the distance between two parallel plate capacitors. So from that we can find out the value of E. So that is E is equal to V by D. So once you substitute the value of E in that above equation, so that equation becomes epsilon naught, so d by dt. So here E is replaced by V by D. So the electric field is electric potential difference divided by the distance between two parallel plate capacitors, or the ratio between V and D, and then area. So the above equation becomes epsilon naught d by dt VA by D. So here I just writing that A, the area, okay, some interchange in that above equation. So that means epsilon naught, I have a A, so then epsilon naught A divided by D and then dV by dt. Okay, so epsilon naught A divided by D and dV by dt, some interchanges, that's it, some interchanges. So here epsilon naught into A divided by D is called as capacitor of capacitance. So here you know that epsilon naught is nothing but permittivity, A is the area, so D is the distance between two parallel plate capacitor, that is called as C. So capital C, that is capacitance of capacitor or capacitor of capacitance. So we know that value of C and also dV by dt. So just substitute the value of C, that is 1 into 10 to the power of minus 6, and dV by dt is 5. So 5 ampere. So once you multiply it, you will get the displacement current of 5 microampere. So the value of C and dV by dt already given in the data in that solution. So that's it. I hope you understand, and thank you so much.